Hi everyone. In this session, we are going to learn about branch penalty in pipelining. We'll see how the branch instructions disturb the smooth flow of instructions in the pipeline and how this delay, that is the branch penalty, affects the performance of the processor. A branch instruction is said to change the normal flow of control in a program. For example, the instructions such as branch equals, branch not equals, jump, call, and return are said to alter the sequence of execution. Sometimes the target address of the branch depends on the condition. For example, conditions like when two registers are equal or not. Because of this, the processor cannot immediately know where to fetch the next instruction from. So this introduces an uncertainty in the instruction fetching, and also it affects the smooth pipelining operation. Fetching the branch instruction. So in a pipelined processor, the instruction fetch stage keeps working continuously. That is, fetching instruction one after the another. But when a branch instruction appears, the CPU does not yet know whether the branch will be taken or not. So it goes ahead and fetches the next sequential instruction. If later it turns out that the branch is taken, those fetched instructions are actually wrongly fetched. So in this case, they have to be discarded and the processor must start fetching from the next target address of the branch. The delay that is caused by this flushing out of the wrongly fetched instruction and refetching the target instruction is said to be the branch penalty. Let us consider a simple example to visualize this. Suppose we have a sequence of instructions. Okay, so ij plus 1, ij plus 2 and ik, where ik is the instruction that is to be executed as this is an unconditional branch, let us assume it. So ij is the instruction that branches to ik. Okay, so in the decode stage, it will be identified that the fetched instruction ij is a branch instruction. So the target address will usually be computed. It will be how the target address will be calculated is the current content of the PC will be added with the branch target address, isn't it? So that gives the next instruction that has to be fetched. So that computation is done in the compute stage. So meanwhile, before the actual branch target address is calculated, ij plus 1 has entered the pipeline and as well as the next instruction ij plus 2 has entered the pipeline. Okay, so if the branch is taken, the pipeline must flush out these two wrong instructions and have to refill it with the branch target. Those empty clock cycles during the flushing of these two wrongly fetched instructions ij plus 1 and ij plus 2. Okay, so the empty clock cycles, the clock cycles that are wasted, that is said to be the branch penalty. That the number of clock cycles lost because of the delay in the branch decision. Delay in the branch decision in the sense branch target address will naturally be calculated in the compute stage. So before it is actually calculated, the other instructions are sequentially fetched ij plus 1 and ij plus 2. But on calculation of the branch target address, it is found that the target instruction is ik. It's not ij plus 1 or ij plus 2. So these two instructions which are already entered the pipeline need to be flushed out and the instruction should be executed from, that is instruction ik should be executed. So the clock cycles that are wasted here due to the branch target address calculation, that is what we call it as the branch penalty. Techniques to reduce the branch penalty. The first method is branch prediction. That is where the processor tries to guess the branch outcome early before the compute stage, whether it will be taken or not, so that it can be fetching the next instruction without waiting. The the technique to reduce the branch penalty is delayed branching, where the processor executes one or more useful instructions after the branch instead of wasting those clock cycles. Another technique is branch target buffer, which stores the recently used branch targets, so that if the same branch appears again, in that case the target address is available immediately. The last and the final technique to reduce the branch penalty is speculative execution, that goes one step further. That is, it allows the processor to execute the instructions from both paths, that is ahead of time, and later discard the incorrect one. All these techniques are aimed to reduce the waiting time and keep the pipeline busy. Thank you.